All right, we're going to continue our work with right triangles, and today we're going to diverge a little bit. Instead of looking at the Pythagorean theorem, which would work for any right triangle, today and our next lesson, we're going to focus on special right triangles. In this case, the type of right triangle that we're going to focus on is an isosceles right triangle. So if our sides, of course, here are the same, of course, we've got our right angle, then that means these two angles have to be the same. Well, if we've got 90, then the other two, of course, would have to be 45, which means that all 45, 45, 90 triangles are similar, right? They'll have all three angles in common, so they're all three going to follow the same pattern when it comes to missing sides. So let's investigate that and see what we can find out. So with this, we don't have to use the Pythagorean theorem. In other words, this is our way around the Pythagorean theorem when it comes to a problem like this. So what we're going to do is we're going to try and find d and what it's worth. Now notice d in this case has been set up as the hypotenuse of this isosceles right triangle. In this case, we have a square that's been divided. So if we follow the Pythagorean theorem for now, we would get x squared, or excuse me, x, squared added to x squared. There we go, we can, right? Is equal to d squared. In this case, I have 2x squareds. So let's rewrite that. 2x squareds is equal to d squared. And remember, we're trying to find the value of d. In other words, I want d all by itself. So let's take our square root here on both sides and see what falls out. Well, the square root of d squared is just d, so that's simple enough. The square root of x squared is just x. And of course, square root 2 is not a perfect square number, so we're going to leave it behind and have a nice exact answer. So if I know the leg measures as x, then I can figure out d pretty quickly. D is simply x times the square root of 2. So for example, let's say instead of x, we knew that these side lengths were 7. Awesome. Well, because of what we just found here, I know a shortcut. I know that this side has to be simply x radical 2, or in this case, 7 radical 2, and it's over. I don't have to use Pythagorean theorem. Since I've done it once, I can use that same process for every single other application, since they're all similar. So this is a theorem. In a 45, 45, 90-degree triangle, the length of the hypotenuse is the square root of 2 times the length of the leg. So again, whatever that leg measurement is, I know the hypotenuse is that measurement times radical 2. It's as simple as that. So let's try a couple. In this case, notice we're going backwards this time. This time, instead of knowing what x is and just multiplying it by radical 2, we're going to go the other way around. So remember, we said that d, this side here, d is equal to x times the radical 2. All right, well, let's fill it in. I know what d is in this case. So d is 6. So 6 equals x radical 2. Well, we're almost there. Remember, our goal is to find x. So here we go. I'm going to divide both sides by radical 2. Since they're multiplied together here, we'll use division to do it. So x is equal to 6 over radical 2. Now, while that's a correct answer, it is not a proper one. We cannot, I repeat, we cannot leave a square root in the denominator. So what we're going to do is something called rationalizing the denominator. In other words, we're going to make certain that this number is whole. We don't want square roots in the denominator. We can if we're doing work, but we don't want to leave it there as an answer. So let me show you what we're going to do. Right now, we've got 6 over radical 2, which is a no-no. Can't do that. So the quickest way out is to multiply by 1. But we're going to multiply 1 in a special way. This version of 1 is going to be radical 2 over radical 2. Notice, radical 2 over radical 2 is another way of talking about 1, so we haven't changed anything, at least not numerically. Radical 2 times radical 2 is just 2, right? Radical 2, just 2. And then 6 times radical 2 is 6 radical 2. Cool. Well, I noticed that 6 over 2 could be simplified. 6 divided by 2 is 3. So 3 radical 2. So let's review. We started here. We put 6 in for d. All right. We divided both sides by radical 2, and we got this, which we said, we don't like that. From there, we multiplied everything by radical 2 over radical 2. So cool, multiplied it out. 6 divided by 2. So in other words, I went from this to this. So let's think if we can figure out a shortcut, so that way we're not having to do all of this. How can we just go straight from here to here? Here's the shortcut. Take whatever you've got, so in this case 6, divide it by 2. So in this case 6 divided by 2 gave me 3, and then just move the radical to the side. All right, we'll do a couple more examples. For instance, let's suppose, again, we've got x's and x's. Let's suppose this number was, I don't know, how about 22? 22. Let's see what we can do. Well, notice if I plug 22 in, just like we did here, I would get 22 equals x radical 2. That means dividing both sides by radical 2. And what do you know? We're right back into the same position we started in. The only difference is the number. So what you do is take your number, in this case 22, and we divide by 2. Notice we did 6 divided by 2. So 22 divided by 2 is 11. And then that square root 2 eventually worked its way up into the numerator anyway. So 22 over square root 2 is just 11 square root 2, or 11 radical 2. So that would be our side lengths here, 11 radical 2. And if you're not sure, well, let's try it. Remember, d is equal to x times radical 2. Well, if I multiply 11 radical 2 by radical 2 times radical 2 is 2. 2 times 11 is 22. So cool, it works. All right, let's try a few more. In this case, we're asked to find both x and y, so let's do that real quick. I know that x in this case is going to be 45 degrees because we're dealing with a square, and of course dividing that out. Let's see if we can figure out y. Y is our hypotenuse in this case. So remember, we said if we've got the leg, in this case 9.6, all I've got to do is multiply it by a radical 2. So y is equal to 9.6 times radical 2. And again, that would be the exact answer. If we wanted an approximated answer, we could type that into our calculator and round it to whatever position we would like. The nice thing about leaving it this way is it's an exact answer and we don't have to do any real work. All right, let's try another one. In this case, y is going to be easy to figure out here. It's also 45 degrees since we're on the square there. Let's see if we can figure out our side length. So we said if we were finding the side, we take our number, in this case 17, we divide it by 2, and then we multiply by radical 2. Right? Well, in this case, 17 doesn't divide evenly, so this would be a perfectly valid answer. If we did want to go ahead and divide 17 by 2, of course we could. That would be 8.5 radical 2. Again, a perfectly valid answer. Either of those would be acceptable. I prefer this one. Personally, I'm more of a fraction person than a decimal person, but either one would work. Again, if you were asked for an approximate answer, we could, of course, type either of those into a calculator. We'd get the exact same answer either way. All right? So let's try this next one. This one's kind of fun. I always like showing it to students. We know that the triangle PAB will be a 45, 45, 90 degree triangle, okay? And the right angle will be at angle B. All right, fine. We need to find the coordinates of P in quadrant 1. So quadrant 1, I'm going to kind of outline it here. That way we know which quadrant it's going to be. And we don't want to forget that. So there it is. For A, at -3, 1, so let's find that. -3, so 1, 2, 3, 1. So here is A. And then B, we're told, is at 4, 1. So let's see here. 1, 2, 3, 4, 1. And that is B. Awesome. Now notice it said that the right angle is going to be at B, and that we want point P to be in quadrant 1. So what I'm going to do is I'm going to see if I can draw that right angle from A to B, so that way it stays in that first quadrant. So it's going to come up this direction somehow, some way, and I'm just going to draw it straight on up just so I can do that. Well, remember, it's 45, 45, 90. So that means that this leg and this leg need to be the same distance. Well, it looks like from -3 to 4, that's a distance of 7. So I'm going to count up 1, 2, 3, 4, 5, 6, 7. So there will be point P in quadrant 1. Notice if I counted down 7 the other way, I could still get a right triangle, but not with P in that first quadrant. So here is our triangle, just as it was requested. And in this case, the coordinates of point P are at, let's see here, 4, 8. So again, we're just looking at those restraints and make sure that everything we've got follows those. Pretty simple stuff. All right. Real quick, special right triangles. If you ever have a 45, 45, 90 degree triangle, then we know that the side lengths here, these legs, if they're x, then that means the hypotenuse is x radical 2. All right. If we're going the other direction, so let's say, for example, that was a terrible triangle, but let's say, for example, that we know the hypotenuse instead. So maybe it's d. Well, then that means that the leg measures, right, we said would be d divided by 2 multiplied by radical 2. So d divided by 2 multiplied by radical 2. So that way you can go in both directions, whether you start with the leg and you're finding hypotenuse, or if you have a hypotenuse and you're trying to find the leg. Bring any questions that you have to class, and we'll see you then, guys and gals.